Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from January 2024 paper 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 11 says light from a laser is incident at 90 degrees to a reflective surface as shown in the figure. Light from the laser is coherent. State what is meant by coherent. This is a typical question. You need to understand what is meaning of this term coherent. Coherent simply means that the phase difference is constant between two waves. Constant phase difference. So this is how you can define what is coherent. Constant phase difference. And constant phase difference is only possible if they have the same frequency. So we can also say they should have same frequency. So this is how you can define coherent. Now let me show you how coherent waves they look like. So you can look at this. Coherent, these waves, they are coherent because they have constant phase difference. Means they have constant phase difference. They are always in step or in antiphase, but the phase difference stay constant. So you can simply understand like these two waves like this, they always go like this. So it means they are in step, so they are coherent. So this is an example of coherent waves. So these waves are coherent and the light from the laser is coherent. That's the reason the light from the laser is very intense. We should not look at laser directly because light is very intense. It can damage our eyes. And if you look at these waves, these are incoherent because they do not have constant phase difference. So these are two examples. This is coherent and this is incoherent. For part B, we need to state why a standing wave forms between the laser and the reflective surface. So here we have reflective surface. And here we have laser. So in this case we need to understand when the waves they will strike the surface, they will reflect back. So they will reflect back. So this is first thing you need to understand. They will reflect back. When they will reflect back, they will combine, they will meet with incident wave and they will form stationary wave. Before we answer this question, we need to understand few points. Conditions for standing waves. When standing waves are formed, first condition you need to understand, traveling in opposite direction. So the waves they need to travel in opposite direction. So we can say traveling in opposite directions. So this is one point you need to understand. And same type of waves, very important, same type of wave. Same type of waves means that sound waves, they can form stationary waves with sound waves, but sound waves cannot form stationary waves with light waves. Mean two different kind of waves. So same type of waves is also very important. And of course these waves, they have to interfere, they have to meet at a point. Interfere, so you can say interfere, or they have to superpose at a point. Meet at a point. In a simple language you can say superpose at a point. So these are conditions for standing waves. Now let me show you the answers, how you can write down the answer. For part 1 you can simply say waves have constant phase difference, and for the second part you can say in this case reflected light waves superposed with the light waves from the laser. So they are traveling in opposite direction, they are same type of wave and they meet at a point, so they will form stationary wave. Question 12 says a circuit contains a filament bulb. When the potential difference across the filament is 8.9 volts, the resistance of the filament is 7.5 ohms. Calculate the time taken for a charge of 5 coulombs to flow past a point in the filament. So in this case we have Q. So simply first of all we can write down we have Q. We need to calculate time and Q is equal to I times T. So if we can find value of I, we can find value of time. So how we can find value of I? For this question, if you want to sketch, you can also sketch this diagram. It is given to us, we have a filament bulb. So this one is the filament bulb. For this question, it is given to us the potential difference across this one is given, so we can connect our voltmeter here, and reading on this voltmeter is given to us, that is equal to 8.9 volts, and resistance of this filament lamp is given, that is equal to 7.5 ohms. Now simply we can use Ohm's law and we can find current in this circuit. So we can simply say in this case I will be equal to V divided by R. So value of V we have, that is equal to 8.9 volts divided by resistance, that is 7.5 ohms. Before we answer this question, let me explain you one thing. This V, this is the potential difference across the component, and this is the current passing through that component. So this is current passing through component. If we have these two values, you can calculate resistance. Now if we simplify this one, we will get 1.19 amps. So this is value of current. We need to find time, so simply T will be equal to Q divided by I. So value of Q is 5.0 coulombs and current is 1.19 amps. If we simplify this one, we will get 4.20 seconds. So this is value of time. So this is how you can write down your final answer. A pretty straightforward question. What question asks you to calculate? First of all, look at that, how you can calculate that quantity, and then look at the data you will be able to calculate. Question 13 says, a glass is filled with transparent hydro beads. The glass is then half filled with water. The beads under the surface of the water seem to disappear as shown in the figure. The refractive index of the hydro beads is very similar to refractive index of water. Explain why the hydro beads are difficult to see when surrounded by water. The important point for this question is given to you is they have same refractive index. If they have the same refractive index, what does it mean? We can use Snell's law. N1 sine of theta 1, this will be equal to N2 sine of theta 2. If n is the same, so we can say sine of theta 1, this will be equal to n sine of theta 2. So n will be cancelled. So it simply means that sine of theta 1 is equal to sine of theta 2. It means that theta 1 is equal to theta 2. So it means no refraction, means no bending of light. As there is no bending of light, so it means we will not be able to see the beads if it is surrounded by liquid of same refractive index. As refractive index is the same, it also means speed in two media is also the same. If there is no change in direction, no bending, it means speed of wave in two media is the same. And this question has 2 marks, so you can mention these 2 points and you will get 2 marks. And so let's try to understand this one with the help of diagram. So imagine that we have medium 1, refractive index of this one is 1.5, and this medium also has same refractive index 1.5. So we can draw this normal line here. Now we can imagine that if ray of light is coming from this medium, this will just go in a straight line. It will just go in straight direction. If it is coming along this line, it will just go in straight line, and so on. There is no refraction. So these 2 points you need to understand. For simplicity, if you see this kind of question where refractive index is the same, you will not be able to see, and this question is very common. You can mention these 2 points in your answer. So this is how you can answer this question. You can mention these 2 points. First point, refractive index is very similar, so it means there will be no refractions at the boundary. As you can see it, light will go in a straight line. Second point, you can say speed is the same. in these two media. Part B says calculate the angle of refraction R, and the refractive index of hydro bead is given to us, means refractive index of this medium is 1.38 and refractive index of air is equal to 1. We need to calculate this angle of refraction. So simply we have to use Snell's law. We can write down n1 sine of theta 1, this is equal to n2 sine of theta 2. So in this case we have n1 that is equal to 1 sine of theta 1. So we have this angle with normal, this is 42 degrees, and n2 is equal to 1.38, and we need to find out sine of r. So from here we can say sine of r, this will be equal to sine of 42 degrees divided by 1.38. We need to find out value of r, so it simply means that sine inverse of sine of 42 divided by 1.38. So if we simplify this one, we will get r is equal to 29 degrees. So this is the answer. So this is how you can calculate. So this tool is very important. So this is very important. So you can label this is medium 1, I'm saying this is second medium, and then you can use Snell's law. Second part says complete the diagram to show what happens to the ray at position x, mean at this point. Your answer should include a calculation. So how we can answer this question? First thing, we need to understand this medium, the refractive index of this medium is 1.38 and refractive index of air, this is 1. So here we have value of n. So light is traveling from denser medium to less dense medium. So it means that total internal reflection in this case is possible. So to answer this question, before we draw the diagram, we complete this diagram, we need to calculate critical angle. So this is very important point. When light travel from denser to less dense medium, total internal reflection is possible if the angle of incidence is greater than critical angle. So for this question, we should calculate critical angle first and then we will sketch. So this is the most important point. So how we can calculate critical angle? Critical angle is angle of incidence. So here we can say this is medium 1, so this is 1. You can also write down here, let's say this is medium 1 and here is second medium. So we can use Snell's law. So we will be writing here n1 sine of theta 1, this is equal to n2 sine of theta 2. In order to calculate value of critical angle, so let me rewrite this one. So we can say n1 sine of theta c, critical angle. So this angle has to be 90 degrees. So this is sine of 90 degrees. So at critical angle, angle of refraction is 90 degrees. So these points we can write down. Now what is n1? n1 is here. This is n1, this is n2. So n1 is 1.38. We have sine of theta c, n2 is equal to 1, sine of 90 is also 1. So from here we can say sine of theta c, this will be equal to 1 over 1.38. We need to calculate theta c, so this will be equal to sine inverse of 1 over 1.38. So if we simplify this one, we will get 46.4 degrees. As critical angle in this case, theta c, critical angle is lower than angle of incidence, means we have 46.7. This is lower than 50 degrees. It means there is total internal reflection. So we can say DIR. Another way of writing this one is angle of incidence. If it is equal to or greater than critical angle, it means there will be total internal reflection if the light is traveling from denser to less dense medium. So these are some important points we need to understand about total internal reflection. So it means in this case total internal reflection will take place. So how we can sketch? So in order to sketch this one, we can simply draw here line, and in this case angle of incidence and angle of reflection, they have to be the same because this is reflection. So angle of incidence and angle of reflection, they should be the same. So this angle has to be very close to this angle. So simply we can place and here. Now if I look, this angle is little small, so I can move a little bit here. So these two angles almost they are the same. So this is how you can draw the line. So we can draw here. So this angle is about equal to this one here. So they are almost equal. So this is how you need to draw the line. Question 14 says a student investigated the EMF and internal resistance of a battery. The student connected a high resistance voltmeter across the battery. The battery was not connected to any other components. Explain why the reading on the voltmeter gave the EMF of the battery. So the best way to answer this question is first of all sketch the circuit. So in this case we have battery. So this one is the battery. This battery also has some internal resistance. So we can say this is the internal resistance and this is our cell. It has some internal resistance. We can say this is R and this is EMF of the battery of the cell, and we connect a voltmeter across this one. So this is our voltmeter, and resistance of voltmeter is very high. So I can simply say this is resistance of voltmeter, means resistance of voltmeter is very high. So this is R. So for this circuit we can say EMF, this will be equal to I times capital R. So this is the resistance of voltmeter plus here we have small r, and in this case value of current, this I, current will be very small. So this current will be very small. This also will be very small. So this is almost negligible. So this is equal to 0. So it simply means that EMF is equal to I times R, and that is the reading on voltmeter. So this is I times R. It means EMF is equal to the reading on voltmeter, because in this case current will be very small, negligible. Resistance of voltmeter is very high, as current in the circuit will be very small. This term will be almost 0 as compared with this one. So the voltmeter will give us reading of EMF of the cell, and this is only true when there is no any other component connected in the circuit. So how we can answer this question? You can simply mention these 2 points. First point, you can say there will be no current in the battery due to very high resistance in the circuit. Means no current means that negligible amount of current, almost 0. So no potential difference across the internal resistance, mean this term will be equal to 0. So these 2 points you can write down. Part B says the student investigated how the potential difference V across the battery varied with the current I in the battery. Draw a circuit diagram for this investigation. Potential difference across the battery varied with current in the battery. If current in the battery is changing, it means that resistance of the circuit is changing. So how we can draw the circuit? So first of all, we can draw the battery. So this is positive terminal of the battery, so this is negative. So this is one cell, so we have more than one cells. So here we have positive terminal of the battery, here we have negative. So it means many cells are connected together, so they will form one battery. And in this case current is varied, so we have to connect ammeter in the circuit, and to vary current we need variable resistor, variable, not variable, variable resistor. So we need, and it has to be connected in series. We need to measure potential difference across the battery. Please look at this one, across the battery. So it means voltmeter has to be connected across the battery. So this is how you can draw the diagram. Part C says the student plotted her results on a graph as shown in the figure. So we have V means voltmeter reading on y-axis and ammeter reading on x-axis. Determine the EMF and internal resistance of the battery. We have already sketched this circuit, so let me draw this again for your better understanding. There is one very important point you need to understand, that one. So we have this variable resistor, and we can connect ammeter here. It doesn't matter, you can connect anywhere in the circuit, it has to be in series. So in this case we have drawn our voltmeter here. So this is our voltmeter. And this battery is not ideal battery. This battery has internal resistance. So we can also draw one very small resistor here. This is representing internal resistance. And this one we can say this is capital R. So the voltmeter reading in this case, so let me connect another voltmeter here. So if I connect voltmeter here, so can you please tell me the reading on these two voltmeters, let's say this is V1, this is V2, is V1 is equal to V2 or not? Take few seconds and write down your answer in the comments, but I will explain you now. So in this case, you see this point, between this point and this point there is no any component. It means potential at this point and this point is the same, and also same is true for this one. Potential at this point and this point is also the same, because there is no component between these 2 points. So it simply means that V1 is equal to V2. So this is very important point, you need to understand like this. Now how we can write down the equation for this one? So simply we can say EMF, this one has to be this reading. This is also called terminal potential difference times I times R. Now if we rearrange this one, we can write down Vt, this one will be equal to EMF minus I times R. So we can little bit rearrange this again. We can say this is minus R times I plus EMF. Now if we compare this one with straight line equation, y is equal to mx plus c. So now you can see from here that this is y is on y-axis and I is on x-axis, and this is over y-intercept. So from here we can say EMF is equal to the y-intercept and gradient. So we can say gradient is equal to minus R. You can say R is equal to negative of gradient. So these are some very important points, and it is possible in tomorrow's exam you will see question about this concept, because this is a typical question, very common question. So try to understand this equation and also this circuit carefully. If once it is not clear, watch again, and if still not clear, leave your questions in comments and ask me where you have doubts, and I will try to explain as soon as possible. Before your exam I will explain you. Okay, now how we can answer? So if we need to find value of EMF, so simply you need to read y-intercept. So you can read y-intercept from here, because x-axis is equal to 0. It is starting from 0. So it means that, let me write one point here. When you can read from the y-axis, if y is equal to mx plus c, this is very important for your paper 6 and paper 3 exam. Y is equal to c if x is equal to 0. Then from the graph you can read directly. Otherwise you have to use the formula y is equal to mx plus c. So in this case, as x-axis is starting from 0, so we can simply read from here. And if you read this one, this is 8.8. So this is 8.8 volts. So EMF simply is equal to 8.8 volts. Now we need to find the gradient, and gradient, negative of the gradient, that is resistance. So how we can find the gradient? So I will be writing here gradient. So gradient we can find out. We can take here this point. At this point, value of y, that will be equal to 0 minus value of y here, that is 8.8, divided by value of x here. At this point, value of x is 3.8. You can read this one. This is about 3.8 minus this point. This is 0. Now if we solve this one, you will get negative 2.3 ohms, but r is equal to negative of gradient, so this is negative of gradient. So value of gradient is minus 2.3, so it means r is equal to 2.3 ohms. So this is our answer. This question is very common. Try to understand this one. Second part says explain why there is a maximum current that can be supplied by the battery. In order to answer this question, we will be looking at this circuit again. And this battery is not an ideal battery. This is a real battery, so it has some internal resistance. So we will say resistance of this one is small r and resistance of this variable resistor is capital R. So we can say EMF, this will be equal to I times capital R plus I times small r. We can rearrange this one. We can say I, this will be equal to capital R plus small r. So from here we can say current will be equal to EMF over capital R plus small r. So from here we can say that when this value of R approaches to 0, mean we decrease this resistance of this resistor to 0. So what we will get? We will get this is EMF, and this is divided by R. So this is the maximum value of current can pass through this battery when EMF is equal to the potential difference lost in the battery, mean the potential lost in the battery due to internal resistance. So this is the maximum value of current, mean I max, this will be equal to EMF divided by R. Because this value is constant, this is constant, so this also will be maximum constant value. So these are the points you need to understand. So based on this one, we can write down our answer. In our answer, you can mention these points. You can say as current in the battery increases, mean when we decrease this resistance, this current will go on increasing, and when this resistance becomes equal to 0, this current will reach its maximum value. The potential difference across the internal resistance increases, mean this potential difference will go on increasing until the PD across the internal resistance equals the EMF, and current can no longer increase. Means when EMF is equal to I times R, and this is maximum value of I. So this is how you need to answer. I hope this question makes sense to you. If this is clear to you, and also if these videos are helping you, please like and subscribe, because your encouragement is very important. And also if you're looking for extra resources, join Patreon. On Patreon you will see a lot of resources. You can find PDF solutions, you can also find video solutions, notes, and a lot more on Patreon. Not only for physics, for other subjects you can also find. And if you have any questions, please leave your questions in comments. I will try to answer as soon as possible.